Dear friends, I myself, Dr. Bharat Parab, discussing the topic Exponents and Powers. Introduction. Consider the number, consider this number is a big number, 1 and many zeros. There are 1, 2, 3, 4, 5, 6, 6 into 3, there are 18 zeros. Such type of numbers are very difficult to read. Hence, these numbers are written as 10 raised to 18, where this 18 is a power and this 10 is a base 10, and read as 10 to the power of 18. Now here the power represents the number of zeros after 1. Number of zeros, there are 18, so 10 raised to 18. Okay. Similarly, 2 raised to 8, that means 2 into 2 into 2 into 2, 8 times. Okay. Or in general, 2 raised to m is equal to 2 into 2 into 2 into 2 m times. Okay. We can see in further part of this chapter that this is also very important. Likewise, powers could be negative as 2 raised to minus 3. This is just a small introduction. So just go through this and we will learn about this in further part of this chapter. That's 2 raised to minus 3 is equal to 1 upon 2 into 2 into 2, that is equal to 1 upon 2 raised to 3 or 2 cube. Okay. And this we will be covering in subsequent videos. Okay. So we move ahead. Similarly, 3 raised to 5 is equal to 3 into 3 into 3 into 3 into 3 5 times, or 3 raised to 0 is equal to 1, or in general a raised to 0 is equal to 1, where a is not equal to 0. We will learn about this in further part of this chapter. 5 raised to minus 3 is equal to 1 upon 5 into 5 into 5, or is equal to 1 upon 5 cube. After learning this, we will have some statement about a multiplicative inverse. So we can say that for a non-zero integer a, remember a is an integer but non-zero, a raised to m, where m is an integer, we are talking about a raised to m. A raised to m is equal to 1 upon a raised to minus m. Here a raised to m is a multiplicative inverse of a raised to minus m, and vice versa, as a raised to m into a raised to minus m equal to 1. We will just go through this, and this will be dealt with in a further part of this chapter. Okay. Laws of exponents. This is a very important part in this topic. These are laws of exponents. We will just go through it and learn them, and by heart this by writing many times, several times on paper. Okay. A and B are non-zero integers. They are integers but not zero. And m and n are any integers. Of course, m and n could be zero also. That is what this says. The first law is a raised to m into a raised to n is equal to a raised to m plus n. When base is same and when they are multiplied, then this power and this power adds to get the total value of this. Okay, m plus n. Go through it. Second one, a raised to m upon a raised to n. When it is multiplied, you are getting plus 1. Then, of course, when it is divided, you get a minus n. So, a raised to m upon a raised to n equal to a raised to m minus n, where n is a or negative sign is goes with the power of the denominator side. Okay. Third one is a raised to m and whole raised to n, that is equal to a raised to m into n. So this multiplies here mn. Very simple. This is very interesting. A raised to m into b raised to m. is equal to AB raised to M. This is same power for different base. Okay. So this A into B, that is multiplied, and the whole to the that power M. Okay. Similarly here, A raised to M upon B raised to M. A raised to M upon B raised to M is equal to A upon B the whole raised to M. Similarly here, as here and here, it's same. This is division and this is multiplication. Okay, so very easy to remember. And the sixth one is a particular case, but you remember this as a laws of exponent. A raised to 0 is equal to 1, where A is not equal to 0. Okay, so do learn them and buy at this. Okay, let us solve some problems or exercise. Okay, go ahead. So exercise or problem, read it very carefully. Simplify and express the result in power notation. Remember this word power notation with positive exponent. These two words are very important. Positive exponent, you know what is exponent? We will see in detail. First one, read it. Minus 3 raised to 4 into 5 upon 3 the whole raised to 4. Answer, write it as it is, and then write it in this manner: minus 3 raised to 4 as it is into 5 raised to 4 upon 3 raised to 4 by using law A raised to m upon B raised to m equal to A upon B raised to m. So we are given this and we are writing it in this manner. Okay, so this is that. Then try to split this. Minus 1 raised to 4 into 3 raised to 4. We have used one simple law for this, and just guess or check which law has been used. This is for your exercise. Okay, and we will solve it. 3 raised to 4 and 3 raised to 4 in the denominator side will cancel, and minus 1 raised to 4 will be 1, and we are left with 5 raised to 4. And we have to express this in power notation like this, and that too exponent or power should be positive. This is positive, so our job is over. Check for the second one. Okay, 2 raised to minus 3 into minus 7 raised to minus 3. So answer, write it like this, and then into bracket 2 into minus 7 and the whole bracket raised to minus 3 by using law A raised to m into B raised to m equal to A into B raised to m. We have learned this and we are using it now. Okay, here A is equal to 2 and B is equal to minus 7. So A into B will be minus 14 raised to minus 3 will be answer. But we have to express in power notation. This is in power notation, but power has to be positive exponent. So this is not. So we are using this law: A raised to m equal to 1 upon A raised to minus m, and the other way around. Okay, so these are equal to 1 upon into bracket minus 14 raised to 3 is this, and we have expressed this in power notation and with a positive exponent. Okay, so this is your answer. We go ahead. Second one, second type means find the value of, in this the first one, read it. 1 upon 2 raised to the whole raised to minus 2 plus 1 upon 3 the whole raised to minus 2 plus 1 upon 4 whole raised to minus 2. The answer, write the whole thing like this, and then by using this law A raised to m upon B raised to m equal to A upon B the whole raised to m, then our number is in this form and we have to write it in this form. Okay, numerator raised to the power and denominator also raised to the same power, as numerator in all the cases is 1, so minus 2 will not make any difference, that will be 1 only. So we are using this formula or this law for each term separately. So look at this. This will be 1 upon 2 raised to minus 2 plus 1 upon 3 raised to minus 2 plus 1 upon 4 raised to minus 2. Okay. Now after this, again for the each term separately, we are using this law. A raised to m equal to 1 upon a raised to minus m. So if anything in the denominator should go to the numerator by changing sign. So we are using the same thing. 2 raised to minus 2 will be 2 raised to 2 plus 3 raised to 2 plus 4 raised to 2. Generally, we prefer to call raised to 2 because by chance there is 2. Had it been more than 5, 6 like that, we would have called this 2 raised to 5 and like that. Okay. So it is better to call 2 raised to 2 plus 3 raised to 2 plus 4 raised to 2. So this is 4, this is 9, and this is 16. So we are writing it, the addition is 29. Okay. We have to find the value. So this is the value. Okay. So read this statement very carefully. Okay. Second one, in this type, finding value, read it very carefully. Into bracket 3 raised to minus 1 plus 4 raised to minus 1 plus 5 raised to minus 1. The whole bracket completes and bracket raised to 0. Answer. Write expression as it is. If 3 raised to minus 1 plus 4 raised to minus 1 plus 5 raised to minus 1, if the whole bracket raised to 0 is always anything raised to 0 is 1, except this should not be 0. Of course, this is not 0. So if anything raised to 0 is equal to 1. By law, a raised to 0 equal to 1. It is given here where a is not equal to 0. Okay. So we are through. Third one, or the last one, under this finding values, read this very carefully. Minus 2 upon 3, this bracket raised to minus 2, and another big bracket which includes this minus 2, this power, this exponent, and the whole thing raised to 2 again. Answer, write the same thing as it is and then try to solve it. Now we have a law, a raised to m whole raised to n is equal to a raised to m into n. The powers or the exponents get multiplied here. So you apply this, minus 2 into 2 will be here. Just see, minus 2 upon 3 will be here, raised to minus 2 into 2, that is m into n. Similarly, this. Okay. Solve this first. Minus 2 upon 3 will remain as it is, and minus this will be minus 4. Okay. So we have used one law. Now another law, a raised to m upon b raised to m equal to a upon b raised to m. We have a term in this form, we have to convert in this form. So we have this minus 2 upon 3 raised to minus 4. So we are taking this m to numerator power and denominator's power. So we're taking minus 2 raised to minus 4 upon 3 raised to minus 4 by using this. Okay. Now using another law, a raised to m equal to 1 upon a raised to minus m. You know this. The powers, if it goes to denominator, we'll get a negative sign. Plus will get minus, and minus will go plus. You know this. You have learned about this. So use this. If you have enough practice, then you will know that you have to just interchange the numerator and denominator and change the sign. Okay. So minus 2 will be in the denominator side, minus 2 raised to 4, if you change the sign, and 3 will go up, 3 raised to 4. Very simple. Now you can solve it. Okay. 3 raised to 4 into, again you split this, you know this formula also, minus 1 raised to 4 into 2 raised to 4. Minus 1 will be minus 1 into minus 1 into minus 1 into minus 1 will be 1. So final answer will be 3 raised to 4 upon 2 raised to 4, which is 81 upon 16, as minus 1 raised to 4 equal to 1. Okay, so this should be your answer. Okay, so go through it, solve as many problems as you can solve, and always write these laws and we'll remember them. Okay, third one, evaluate. First one under this, look at this expression. Into bracket you get 1 upon 3 bracket raised to minus 1 minus 1 upon 4 raised to minus 1, and another bracket, all this in bracket raised to minus 1. Don't get scared of this many brackets and negative exponents. Such type of problems are generally very easy. Okay, so answer, write the whole expression as it is. Now 1 upon 3, if you use this law, a raised to m equal to 1 upon a raised to minus m, you know this, that sign of exponent changes when it goes in the denominator. So here also I have left one step in between for you to think and write it. Okay, so 1 upon 3 is equal to 3 if you use this, and 1 upon 4 will be 4, then minus sign remains as it is, and this bracket raised to minus 1 is still there. Okay, so solve this bracket first, that will be a minus 1 raised to minus 1 equal to minus 1. Try such some problems, and while solving such problems, always do remember all these laws and signs. Okay, so we move ahead. Evaluate continues. Second one, read it. 5 upon 8 raised to minus 7 minus 8 upon 5 raised to minus 4. Okay, answer, rewrite it as it is. 5 upon 8 raised to minus 7 into 8 upon 5 raised to minus 4. And if you look at this minus 4, there is a scope to get minus 4 here also. So you write this minus 7 as minus 4 and minus 3. So you write it as 5 upon 8 whole raised to minus 4 minus 3 into 8 upon 5 raised to minus 4. Now separate this. Okay, 5 upon 8 raised to minus 4 into 5 upon 8 raised to minus 3. Okay, why this is multiplied? If you don't understand, write to me in the comment section. Okay, or it's better if you try to understand it. Okay, so I separated these terms into writing this term as it is, 8 upon 5 is to minus 4. Okay, now you know this famous law, we have been using it for many problems. So if you interchange this will be plus. Okay, 5 upon 8 will be 8 upon 5, and this will be 4. Okay, plus 4 into 8 upon 5 raised to minus 4 into 5 upon 8 raised to minus 3. This carries as it is. Okay, now use a law for this. 8 upon 5 raised to 4 minus 4 into 5 upon 8 raised to minus 3 as it is. We will continue on the next page. Okay, so evaluate 2 continues. This was the step from the last page is written here. 8 upon 5 raised to 4 minus 4 into 5 upon 8 raised to minus 3. Now 4 minus 4 is 0. So 8 upon 5 bracket raised to 0 into. Now look at it. Here is a 5.8. We have written it or interchange the numerator and denominator, 8 upon 5. So the exponent will change the sign. Okay, So 5 upon 8 raised to minus 3 will be 8 upon 5 raised to plus 3. Now this is 0. This we have used this law for this. A raised to m equal to 1 upon a raised to minus m. As this is 0, this will be 8 cube upon 5 cube. Check out which law has been used for this. This one will go, and 8 cube upon 5 cube is be 8 into 8 into 8 upon 5 into 5 into 5, and that will be, if you do all this multiplication, 512 upon 125. That's your answer. Okay, so move ahead. Fourth one, simplify. First one under this type. Read it. 25 into t raised to minus 4 upon 5 raised to minus 3 into 10 into t raised to minus 8, where t is not equal to 0. This is the condition given. Answer, rewrite it as it is. 25 into t raised to minus 4 upon 5 raised to minus 3 into 10 into t raised to minus 8. Okay. Now express 25 as 5 square. We are taking all in square, so that will be very easy for us to solve. So write 25 as 5 square into, copy this, t raised to minus 4 as it is, divided by 5 raised to minus 3 into 2 into 5. Express this 10 as 2 into 5 into t raised to minus 8. Now you can apply law. This 5 raised to 2 plus 3 minus 1. Okay. See which law we have used. I have deliberately not written this, but you have to write it in exam. Just check which law has been used here. Okay. 5 raised to this whole raised to, this is 2 plus 3 minus 1. Okay. And again into t raised to minus 4 plus 8. These two should not forget. Divided by 2, all other terms have gone up. Okay. Now solve it. 3 minus 1 is 2, so 5 raised to 2 plus 2 is 5 raised to 4 into this 8 minus 4 is t raised to 4 divided by 2. Okay. So this is 625 into t raised to 4 upon 2. That's your answer. Okay. See which law has been used. There will be more than one law have been used, and read, solve this and write those laws, because you need to write all these laws in the exam. Okay, this was just for you to brush up the laws. I have not given the laws. Okay, move ahead. Second one, 3 raised to minus 5 into 10 raised to minus 5 into 125 upon 5 raised to minus 7 into 6 raised to minus 5. Okay, answer, write it as it is. I have written this 10 into a red one for some reason. Just you have to concentrate on systems where there are this expression contains 3 and 5 many times. So try to write other terms in the form of 3 and 5. Okay. So copy this 3 raised to minus 5 as it is, and write this 2 into 5 raised to minus 5 into 125 as 5 cube. Okay. Use this law. Okay, a raised to m into b raised to m equal to ab raised to m, and this 5 7, and they write this 6 as 2 into 3 raised to minus 5. Now try to separate this by using this law. 3 raised to minus 5 into 2 raised to minus 5 into 5 raised to minus 5. You know why it is 5 cube, 5 raised to 3 divided by 5 raised to 7 as it is, then 2 raised to minus 5 and 3 raised to minus 5. Okay, you know which law has been used. Now 3 raised to minus 5, 3 raised to minus 5 cancels. 2 raised to minus 5, 2 raised to minus 5 cancels. And you are left with only powers of 5. And see, is minus 5 plus 3, and this is in the denominator, so it will go up with positive sign plus 7. Okay, so this addition is 5. 7 plus this 10 minus 5 is 5, so 5 raised to 5. Okay, so generally if you come across, when you come across such type of problems where it is big numbers, generally such type of problems are very easy. Only the thing is you have to use proper law, proper uh, sign convention, and use it in a proper way. Okay, you will get it by some practice. Okay, so let us conclude this. This is Dr. Bharat Parab helping you in your studies. If you have any difficulty in this topic, let me know through comment section and I shall solve it. Thank you. Good luck.